One of the important issues in band structure analysis is which orbital contributes at each band and each K point. This information gives us much about the physics behind the material, and it is so attractive for researchers. The band that indicate the contribution of orbitals is called the projected band or fat band. We want to train how we can do this by using quantum espresso. You can see this figure is for projected band for MOS2, one of the new materials. Now we want to train how we can do this by using quantum espresso. We open the PWGUI graphical interface and we choose File, New, and projwfc.x. We choose the prefix the same as self-consistent field calculation. I mean graphene SCF. In the directory, we define the root of band structure folder. In this section, we define the file that projection data is written on it. For example, I define gr projection .dat. At the end, we save the file in the band structure folder. We save the file in the band structure folder with the name of gr.pr.in. We can see the created input file here. Then we open the terminal environment and run this input file. We open the terminal environment and we write mpi run projwfc.x, the name of input file, that is gr.pr.in, and the name of output file. After the run is over, we see the several new files have been created. If we look at the output file, this is the output file. If we look at the output file, I mean gr.pr.out, we can see that 8 states are specified. What are these 8 states? In the unit cell, we have 2 atoms, and each atom has 4 orbitals. Therefore, we have 8 states. 4 orbitals include 1 s orbital and 3 p orbitals. For example, state number 1 belongs to 2s orbital for the first atoms. In this case, L equals 1 and M equals 1. This state related to pz orbitals. Thus, state number 2 is for 2 pz orbitals of the first atom. M equals 2 related to px orbitals, and the state number 3 is for 2 px orbital for the first atom. L equals 1 and M equals 3 related to py orbital, thus state number 4 is for 2 py orbitals of the first atom. State number 5 is for 2s orbital of the second atom. State number 6 is for 2pz orbital of the second atom. State number 7 is for 2px orbital of the second atom. And at the end, state number 8 is for 2py orbital of the second atom. If we look at the input file description and information in Quantum Espresso website, we can find these informations. As you can see, for L equals 1, when M equals 1, it indicates pz orbital. When M equals 2, it indicates px orbital. And when M equals 3, it indicates py orbital. Therefore, these numbers indicate which orbital is considered. The similar information exists for d orbitals here. There are another file here, this file, the grprojection.dat. If we open the grprojection.dat file, we can see that this file contains projection. We see that there are 3 columns for each state. For example, for state number 1, you can see 3 columns. The first column belongs to K point. The second column belongs to number of bands, and the third column represents the weight of that state or that orbital. For example, this. The weight of 2s orbital of the first atom, which indicate first state on the K point number 25, and at first bond is 0.25. All of this information is for state number 1. For state number 2, for the next state, we can see another 3 columns. Indeed, we can see these 3 columns for every 8 states. This information is for state number 2. First column indicate K point, second column indicate band, and third column indicate the weight of that orbital. You can see state number 3. This is state number 4. If you remember, state number 4 is for 2py orbital of the first atom. And then we can see state number 5. It is for 2s orbital of the second atom. State number 6, it is for 2pz orbital of the second atom. State number 7, it is for 2px orbital of the second atom. The last state, state number 8, is for 2py orbital of the second atom. First column indicate the number of K point. Second column indicate the number of band. And the third column is the weight of that orbital on that K point and that band.